Hey folks, this is Anant. I'm a software engineer with Ahana, and today I'll be chatting about a feature that we've been developing for our customers called Quick Stats. It's an optimizer feature. Um, Let me just get right into it. So as we know, statistics are the backbones of good query plans. You really need up-to-date statistics for the query optimizer to be able to make correct costing decisions and being able to apply the right selectivities for any sort of non-trivial queries. And this is something that we have observed for our customer workloads, that if a customer is running, let's say, queries on a brand new table, or they are running it on a new partition for data that was recently loaded. Um, the the query plans that were coming out were pretty terrible because there were no statistics. Presto was reporting unknown as statistics for the table, for the partition, and for the columns. Um, we did a little more deep diving as to what could be done to address this, and obviously the go-to solution that is recommended is to be able to run analyze on any new data that has been inserted into a table. But this can become costly, and this is not as easy as it seems, because frequently there will be a challenge as to understanding what partitions were updated, um, as well as what was the last time this operation was done. And while there are chances that you can work around it and build these knobs into your ETL pipeline, this is something that is frequently missed. Yet another way that you could run into this issue of not having statistics for your query plans is if you're running with a non-Hive metastore. So let's say you're running queries against your iceberg or Hudi tables, and you're just bringing them online for the first time. You may not have the backing statistics for your data, and the optimizer is just going to be making guesses. It's only going to be doing any sort of join planning with the syntactic join order that it sees. So what can be done here? Um, what we realized was, by looking at our customer workloads, that there are other metadata sources that could be exploited to build a what we were calling a quick version of the statistics, so that the optimizer is able to use some of this data and uh, build a model that it can actually do somewhat decent joint planning on. Um, so uh, the different sources that I was talking about, like Iceberg or Hoodie, I won't go into the details of those, but they're kind of similar to what sort of statistics you get from file footers of these popular file storage formats like Presto and ORC. So you get min values, max values, null counts, um, and total cardinality for a file. And these can be summed up to understand the cardinality and all these statistics across the partition that we are querying. Um, what we realized was that you are anyhow going to be querying all of these logs and doing file listing. So there's a chance that we can do this in a bounded way, uh, build these statistics in line with query execution, and and cache these statistics so that we can use them for future queries which comes in. Um, so very quickly, this is what, let me just go full screen to look at this a little better. So this is what the flow looks like. A query comes in, and the planner figures out which are the partitions for that query which are missing stats. And by plugging in this quick stats provider, we can check if you already have statistics which were cached in a previous run. If so, then we're all well and good. Otherwise, we would be doing directory listing, and frequently this directory listing is through a cached directory lister, which means that there is no extra incurred cost for doing this extra directory listing. And here is where the list of files that you get back, you can apply in this pluggable model, different kind of strategies to figure out uh, what kind of stats are available and can be stored for future use. And so let's say, you're running against a Parquet-based schema. Like I was mentioning, you can get all those statistics around min, max, null counts, and overall cardinalities. Um, so I wanted to show the results that uh, we got from our initial testing. Here I am running short stats on a TPCH scale factor 100 Parquet schema. And as you can see, Presto is reporting that we have absolutely no stats. We don't even have overall row counts. And of course, what this means is any sort of querying that you do ends up with really, really poor plans. And so here I've shown a screenshot of the join differences, and I don't show them completely for all these queries, but for the 22 TPCH queries, except for Q1 and Q6, every one of them had some sort of plan diff that meant that you would get poorer execution, and I'll show the latency for this execution later. Um, Here's an example of that plan diff. Um, so as we can see, if we had all sort of statistics, we would be doing a join for the smaller table, then slowly building joins with slightly bigger tables, and the optimizer would be doing the right thing uh, in building a plan which has a decent bounded execution time. But without stats, we just get a execution which is just in syntactic join order. So how does quick stats change this picture? By setting this session property now, when you do show stats for line item, and in this case, I was running it against a Parquet based schema. So I was able to utilize the Parquet stats and get min and max values for all the columns and overall row count, as well as the nulls fraction. For the TPSC schema, we're well aware that there are absolutely no nulls for these columns, so that's why these values are 0. Um, and so this resulted in much better uh, situation here where we're seeing there are still a few plan differences, but it is not as bad as what we had uh, without any statistics. And again, looking at Q2, um, we got most of the the subplans right. So here we are joining nation region and then joining with supplier. We did get some, you obviously didn't get exactly the same plans as you would because you don't have some of the statistics like the NDVs and the data sizes to make the right decisions. But the optimizer was able to do a better job. Um, and jumping ahead right to the latency graph, you can see that uh, the query plans which are in blue were the ones, sorry, the queries in blue were the ones which were mostly performing worst in our comparison with the TPCH SF100 non-partition schema. But as soon as we added quick stats in this operation, you know, is in line with query execution, but these numbers for latency are uh, for cached query stats. Um, uh, we are seeing much better execution times. Um, so what are the gotchas here? Are there any to begin with? Like I was saying, we don't get number of distinct values. At least in the Parquet file footers, there are no uh, there's no way to store HLL sketch that most writers can use to then later build out total NDV counts. And so because of this, we had to actually go ahead and add another feature called default join selectivity, which is what I was showing before in our plan compare was 0.1. And this is a factor that we apply anytime we're doing a join so that anything beyond a two-table join um, can uh, come into a good shape. Um, and so that was one of the challenges that we saw with just having basic quick stats. Um, the next steps that we have for here for this project is, we're going to build out some of the other strategies like the iceberg quick stats builder strategy, and at the same time look into sampling and see how we can use sampling for getting better NDV estimates. Um, quick stats will has obviously helped, and we've got decent performance, but to get to the next stage we would need to get uh, analyze samples to get us to the finish stage. Thank you.